Okay, so lesson 5, we're skipping lesson 4, all right? So we're going to look at solving some exponential functions, okay? Like how do you solve for an exponent, variable up in the exponent? Well, they had this method of common bases, they call it. I don't think they're super clear enough about it right now, so I want to give you a quick note here. Whoopsie daisy. Of course, I always do that. Nothing new under the sun. So let's go to our notes page real quick. Over here, okay? So let's talk about common bases in a very simple sense. And this is pretty simple, right? So if I have b to the a, right, whatever those numbers are, and tell you it's equal to b to the c, right? So they're the same base, whatever, the same number, b and b, right? B to the a, if that equals b to the c, what could we say about a and c then, guys?
A equals C.
That, right, then those exponents must be equal, right? Then a equals c. So this is one particular method of solving, right? If you have the same base and they're equal, then the exponents must be equal, okay? This is solving with they call the method of common bases. And we'll learn some other methods later, right? But, so if everybody has that, let's go back here. So they want us to solve each one of these by writing each side of the equation using a common base. So we have to think about this a little bit. So look at 2a or 1a here. We have 2 to the x equals 16. Could I rewrite 16 to some, like, as a base of 2 to some power?
Yeah.
16 is 2 to the what power, kids?
It's 2 to the 4th power.
2 to the 4th, right? So that's equal to my 16. So now, do I have what I just wrote on the notes page? So I have b to the 8
Yes,
b to
that
the c.
means X equals 4.
There we go, right? So x must equal 4. You just solved your first exponential function, okay, for variable up top. Let's try part B. Be nice if I could rewrite that 27 with a base of 3, wouldn't it? Could I?
Yes.
Okay, 27 would be 3 to what power? Use your fingers if you need to. 3 to what?
3.
3 to the 3rd, right? Because 3 times 3 is 9 times 3 is 27. So 3 to the 3rd, right? Okay, now we have the same common basis, so it must mean that what?
X equals 3.
X equals 3. All right, let's take a look at C. Slightly different, right? We have 5 to the x equals 1 over 25. Could we write 1 over 25 as some power of 5?
Yes.
5 to the what?
5 to the negative 2.
Negative 2, right? That's how it got made a reciprocal, right? In other words, 1 over 5 squared, wouldn't it be? So what does x equal in this case?
X equals negative 2.
Yeah, simple enough, right? And this last one here, 16 to the x, right, equals 4. What could we do here? There's like a couple ways to do this. Could I rewrite 16 as something else? Like a power of 4.
Yeah, 16 would be the power of
4 to the what?
4 to the 2.
4 squared, right? So watch carefully. Like there's already an x up here, right? But I can rewrite my 16 as 4 squared, and that would be a power to a power. So wouldn't that 16 to the x be the same as 4 to the 2x?
Yes.
Equals 4 to the what? What's
4 to
the
the 4th.
first power, right? Well, now there's one more little step, right? Now we kind of have an equation, don't we? What would be our equation to solve?
2x equals 1.
So x equals 1 half, right? There's another way to do, there's a couple ways to do this, right? Let's try and keep them as both a base of 16. How about 16 to the x equaling, let's rewrite the 4 as 16 to some power.
16 to
To the what?
the 4th.
No, 16 to the first is 16. I want to be able to turn this 16 into a 4. What do you do to 16 to get 4, by the way? Take the what?
Divided by 4.
No, well, take the what?
Square root.
What's a way to write square root as an exponent from yesterday?
Neg
To the what?
1/2.
16 to,
Negative 1/2.
16 to the 1/2, right? Wouldn't 16 to the 1/2 be the same as 4? And now I have common bases, don't I? So now I can just say x equals what? 1/2, that way. Boy, there's another way to do it. Let's think about this. Could I write both of these as powers of 2? Let's take the 16 to the x. So 2 to what power gives you 16?
2 to the 4.
2 to the 4th power, right? So 16 to the x can be rewritten as 2 to the 4x. You with me? Equals, now let's take this 4. That would be 2 to what
2
power?
to the 2nd power.
2 squared, right? Now what's my equation? I've got common bases.
4x equals 2. Which
Divide
means
by 4 does x again,
equals 1/2.
right? When you put it, okay? So you see there's more one way to skin a badger with these sometimes, right? And some of your brains will see something different than other brains, but there's more than one valid way to do these, okay? All right, let's look at the exercise 2 down here. They want us to simplify these expressions, right? Shouldn't be too hard. We've already kind of done that, right? We've done this here, but let's take a look at 2 to the 3rd to the x power. So that's a power to a power, so this becomes 2 to the what power?
2 to the third.
2 to the 3 times x, right? You multiply. What about part B? This would be 3 to the what?
3 to the 8th.
3 to the 8x. 2 times 4x is 8x, right? And what about C?
Negative 3x plus 7.
Yeah, if we have to kind of distribute the -1 through there, right? So it'd be 5 to the -3x plus 7. All right? And this last one would be 4, let's just write it out. -3 times 1 minus x squared, right? So that would actually be 4 to the what?
That would be 4 to the third.
-3
Negative 3 plus 3x squared.
x squared. And I prefer to write this algebraically correctly, so maybe I'll just write it as 4 to the 3x squared minus 3, right? That's the same thing, isn't it? That's just more proper polynomial form, right? Start with the higher exponents. Okay. Why don't you guys try these down here, okay? Let's, I'll walk through the first one there, and then I'll turn you loose here. So let's try this. 8 to the x equals 32. Let's solve for x. So we need a common base for both of those. So the first thing I'm going to ask, 8's the smaller number, right? Is 32 some power of 8?
No.
Like 8 times 8 goes right to 64, right? So no. But maybe there's another common base for these guys.
The common base would be 4.
Okay, 4 times 4 is 16, times another 4 is 48. It doesn't hit 32.
Oh, no.
So maybe there's a different common base.
2.
2, right? So 8 to the x would actually be 2 to the what?
2 to the third x.
3x, right? And then 32 would be 2 to the what power? Go ahead, use your fingers.
2 to the 5th.
2 to the 5th, right? 2 times 2 times 2 times 2 times 2. I think I said 5, right? 2 to the 5th power. Now we have a common base, right? So we kind of manipulate both of them. What's our equation now to solve for x, everybody?
3x equals 5.
And then divide both sides by 3, and you get x equals 5/3. All right, you can get the idea there? Okay, so why don't you guys take a crack at B and C over here, right? Find a common base for each of them. And once you get a common base, just set the exponents equal and solve them like you did in kindergarten. Okay, I'll give you a couple of minutes. Okay, so 9 to the 2x would be 3 to the what?
3 to the 4th. 3 to the second parentheses 2x plus 1.
Right?
Then it'd be equal to 3x, 3 to the 3rd.
3 to the 3rd is our 27, right? Everybody with that? So that first one there, we powered up, we got a but now we got to distribute, right?
You know, distribute the 2 to get 4x plus 2.
Equals 3, right? So if I lose somebody, say something, okay? Subtract 2, we get 4x equals 1.
Divide the 4 to get 1 4.
X equals 1/4. Does anybody have any questions on that? So you got to think in your brain, right? Common bases. You know, you count with your fingers if you have to. You know, that's why I'm trying to get you guys to put the calculators down and develop some number sense here, right? All right, I'll give you another minute there on part C. See who comes up with that one. So that'd be 5. Well, not just 3. 5 to the
3x.
3x, right? Equals, now this thing, 1/25 would be 5 to the what power?
Negative 2.
-2, but, right, we got that exponent up there. Right? So,
Mhm.
Antonio, was that what you had there, Antonio?
Why is it 2?
Well, 5 to the -2, sorry. Is that what, yeah, -2.
That's awesome.
I was just right. Paul, you didn't say -2. Did you say -2?
Oh,
Paul, you're trying to, you're messing with me a little bit, buddy.
I didn't say anything.
Okay, we'll leave it at that. So to the -2, right? To make it the reciprocal. So now what's our equation?
Can the equation be 3x equals -8 plus x plus 2x?
That might be where your mistake was, right? Was that your mistake, Antonio?
Yes.
There you go. What? Just who's touching my, like, who did that? What is going on here? So then we have 3x equals -8 plus 2x, right? So if we subtract 2x from both sides, it's pretty simple, right? We just get x equals -8. All right? Does anybody have any questions on that guy? Okay. Let's go down here. Which of the following represents a solution set? Why would it be a set, I wonder? I don't know. To 2 to the x squared minus 3 equals 64. So in other words, what's the solution set? We have to solve that. Hey, notice there's a bunch of plus or minuses in these answers, right? So let's set this up then. What would be a common base for this?
Common base be 2.
Okay. So we don't have to do anything on the left side, right? So we'd have 2, because that's already a base of 2, x squared minus 3. And our 64 would be 2 to what power? Use your fingers if you need to.
2 to the 6.
2 to the 6th power, right? Okay. So our equation then would be x squared minus 3 equals 6, right? In other words, x squared equals what?
X squared equals 3.
No.
Oh no, x equals 9.
X squared equals 9, right? But now what do?
We square. We
Take the
root
square root of both sides, you get x equals what?
X equals plus or minus 3.
plus or minus 3. Two answers, right? Plus or minus 3. Everybody good with that? And that would be, what is that, choice 1 over there. Okay? All right, let's go over to the next page. And I'm going to kind of modify a little bit what they're getting after on the next page in exercise 5. Okay? Let's go over to the next page. So we have two exponential curves here, right? As you can see here in the diagram, we have this one here, which would, you all agree it's growth, right? And this one here would be what? Not growth, decay, right? Okay. And so they've given us the equations that make those two. And notice the two graphs intersect somewhere, right? So where two graphs intersect, that's the same as saying that the equations are what at that point?
That they both are inverses.
No, not inverses. If two lines intersect, then their equations are what at that point? They have the same value, so they are equal. Yes. Okay.
Yeah.
And here's our two equations, right? This one here, I'm going to use red. Y equals 4 to the x plus 5 over 2. Would that be the one that's growth or decay? The one I just underlined. The base.
That'd be growth.
That's growth, right? And the other one is
Because
y
the
equals
base is 4.
yeah, 1/2. The base is between 0 and 1, right? So that's going to be decay. That's a decay, and they've labeled it here, right? So you see this one's the growth one, and this one's on the decay one, okay? And they got this rectangle in here, which starts at the origin, like at 0, 0, right? And then this point A. And then we're talking about finding the area. I don't really, there's another important part to this. So to find the area, a rectangle, what do you need? You need his base and height, right? And part B, how would finding the coordinates of A help us find that?
Because we know the height.
So A is at some, well, we'd also know what, right? A would be some XY, right? The XY of A, right? The distance X to the left and Y up, wouldn't that be the base and the height? So that will give the base, right, which is the X value, and the height, which is what value of A?
The Y value.
Right, which is the Y value. And once you get those, you can multiply those, right? And so point A is where the graphs intersect, right? So A is where our two equations are equal, right? So is where 4, what is it, to the x plus 5 over 2 equals our 1/2 to the 2x plus 1. Does that look something, what I just wrote, does that look like something that we were just solving?
Yes.
It does, right? So we're just like, it's in another context now, but is it really just not the same thing? Okay? So if we get this distance, right, that's our x value, isn't it? And then this distance, our height, that's our y value, is it not? And that's the coordinates of A, x comma y. You with me on that? So how can we find that x value if we know that A is where this happens? How can we find the x value?
We can find it by
Solving that equation, right? So we use the method of common bases to solve that equation and get our x. And then we can plug it in and find the y, couldn't we? So let's solve this equation, right? Let's write it down. So we have 4 to the x plus 5/2 equals 1/2 to the 2x plus 1. So they want us to use common bases to solve this. What could we rewrite each side with as a common base? What base do you think?
the common base would be 2.
2, okay. So 4 is a power of 2, right? So 4 we could write as 2 to the what?
to the second
What, times the thing that's already there, right?
x parentheses x plus 5 2.
Okay, and the other side, that
Equals-
1/2 would become a 2 to what power?
2 to the negative 2.
Hmm,
Oh no, 2 to the negative 1.
2 to the negative 1 power, right?
Parentheses 2x plus 1.
Okay. Did I lose anybody there? All right, so now we can solve these for x, can't we? Can't we? So what's our equation here?
The equation would be 2x plus 5 equals,
I'm just going to write it down while distributing first,
Okay.
right? So now let's think about, okay, so let's go ahead and distribute then. It's 2x plus, these 2's will
5.
cancel, right? 5 equals what?
equals negative 2
Negative 2x.
x plus 1.
Ah,
Minus 1.
you got to distribute the negative all the way through, right? Okay. So what we're going to do now? Let's get all our x's on the left-hand side, shall we? How are we going to do that?
We add
What?
a negative 2
Add 2x to both sides, don't we?
and 2x, which would be 4x
Plus 5 equals negative 1, right? We added 2x to negative 2x, it's gone. I'm not writing down those little baby steps anymore that you did in algebra, right? We're at a different level now. If I lost someone there, say something, right? Everybody good with that step? And now we subtract 5 from both sides, right? So 4x equals what?
4 equals 6.
Negative 6.
X 6.
Yep.
Which divided by 4, we get negative 6/4,
And let's put that in lowest terms, please.
which would be negative 3 halves.
Yeah, actually, like if we're going to plot this and use it for distance, let's go ahead and get the decimal version of that. Be negative what? 1.5? Like if you're going to plot something in the coordinate plane, right? I want you to go left 6/4. Wait, what are we talking about? Let's go left 1.5. How about it, right? Does it make more sense if we do it like that? Okay. Well, that would be our base for the rectangle, wouldn't it? Would we disregard the negative for the base though, like in geometry, remember? The base would just be a length of 1.5, right? Now, how do we use this to go back and get the y value?
We would insert as x equals,
Into
insert it into the
which equation?
formula,
Does it,
the height formula.
there's no height formula. We're
The
going to plug
formula
our
A.
x into one of those
Formula.
equations. Does it matter which one we plug it into?
No,
No, because they're both equal at that point, right? So I guess the rule is to pick the one you think will be the easiest. Like which one? I don't know. Which one do you want to plug x back into?
otherwise, like 1/2.
Yeah, all right. Let's use a y equals 1/2 of the 2x plus 1. Let's do that one. So y would be 1/2 to the 2 times negative 1.5, right? You get that right? Negative 1.5. Yeah, plus 1. Sorry, I want to make sure. Can't see my screen when I'm scrolling. Plus 1, right? Is that what it was? Yeah. Okay, so let's simplify that exponent. 1/2. What's 2 times negative 1.5?
Negative 3.
Negative 3 plus 1, right?
The
1/2 to the negative 2, right? But we know what to do with that, right? That'd be y equals what?
y equals 4.
4, right? So now we have our height. Then you could multiply those and get your area, right? Just don't use the negative, okay? But anyway, so the coordinates of A then is really the important thing I wanted to find, where they intersect. with the coordinates negative 1.5, comma, 4. This is stuff you kind of done in algebra. We're just doing it now with exponential functions, right? A little bit of
This
work.
one's geometry.
Yeah, I guess we did, but we didn't do exponential stuff in geometry. We did do area, Paul. So let's go label that, right? So our A here, if we bring this up, that point is our negative 1.5, comma, 4. And that's the base and height of the rectangle. All right? So the key is, right, if you've got two equations and you want to know where they intersect, you know this from algebra, right? When you took algebra there at Tots Learning Center, right? You set the equations equal and solve them, okay? That's where the graphs intersect. All right, let's go down here. I think it's the last question. Okay, so what x coordinate will the graph of this guy intersect with the graph of that guy? Well, what did I just say? What do you?
We'll use the separate of common basis.
Well, you set the two things equal and then solve it, right? Just like we did up top. And they're not even asking for the y, are they? They're just asking for the x coordinate, right? One of these. So we didn't have to plug back in. So you guys are going to set the two equations equal, right? So we'll have 25 to the x minus a equaling 1 over 125 to the 3x plus 1. So you'll need a common base, right? So I'm going to give you all a couple minutes, plug away at that, and let's see who comes up with it. What was the common base that you used?
The common base is 5.
Okay, so on the left side, we rewrote this as 5.
5, 1, 2, 1, C, x minus a
To the x minus a equals
Equal.
5 to the what?
5, negative 3 to negative 4,
Right, times
plus
3x.
3x plus 1.
There you go. So now we have common bases. Those exponents
So the
must be
base
equal.
would be 2x
Distributed
minus
through, right? Yep.
a
Minus
2a
2a. Yep.
equal negative 9x minus 3.
Minus 3, right?
We would add plus 9.
Add 9x to both sides, right? That give you
Yeah.
11x minus 2a, right?
And then add the 2.
And then
Add the 3.
So then we have, well, no, let's add the 2a. I want to get the x by
Right.
itself. 11x equals, would be, let's see, 2a minus 3 if we add 2a to both
Then
sides.
divide by 11.
And then divide both sides by 11. 2a minus 3 all over 11. Okay? A lot of you guys, you're not really piping up there, but please, if you have a question on this, ask away. Don't be scared. Don't be nervous to be wrong. Does anyone have any questions on this? Did we lose you anywhere? All right, so the gist of this one, right, is solving by, and we'll learn another solve because, you know, later on, you won't be able to find a common base for both sides, but they're all kind of set up that way. So, but we'll learn about logarithms later. But right now, to find a common base, then the exponents must be equal, right? And if you have, you know, two equations that have graphs that intersect, how do you find the intersection point? What do you do with the two equations?
You intersect.
You set them equal and solve them, right? All right, everybody with me? Okay.